In order to do parallel line proofs, we need to discuss some properties that we're going to use. Our goal is to be able to take parallel lines and then prove things that occur because those lines are parallel. So we do this using a method called two-column proofs, and it's basically just a way of being able to write our statements and state our reasons. So it's just like we do in class. What do you know and why do you know it? So step one is always going to be the given information, and the last statement will always be the part that you're trying to prove. So it's what you're proving. So some properties that will come up a lot when we're doing this is, one of them is substitution. So if A is equal to B, then A can replace B in any equation. We use this all the time. We substitute all the time, but this is just putting it into words. If A is equal to B, then I can take A and replace it with B in any equation that I'm working on. The transitive property is just a special substitution property, and it says this, that if A is equal to B and B is equal to C, then I can cut out that middleman. What do I even need B for? And I can just go straight to A is equal to C. Okay, so then we have the congruent supplements property, which is kind of similar to the transitive property, but it says this. So remember that supplements are angles that add to 180 degrees. So it says this, that if angle A and angle C are supplements, they add to 180 degrees. And if angle B and C are supplements, shorthand that, then it must be true that angle A is equal to or congruent to angle B. Angle A is congruent to angle B. If A and C add to 180 and B and C add to 180, then A must be the same as B. And lastly, we have our algebraic properties of equality. And basically, all that says is that what you do to one side of the equation, you have to do to the other. So if A is equal to B, then I know that A plus C is going to equal to B plus C because I'm adding the same thing to both sides. That's addition and subtraction. I can also say A minus C is equal to B minus C. And so this is just like how this would come up when you're doing an algebra step in a proof. We've got if A times C is equal to B times C. And the same would be A divided by C is equal to B divided by C. So those would all be the same thing, but basically it's that algebra property of whatever you do to one side, you have to do to the other. So let's look at how to write a proof. So we're given that J is parallel to K and K is parallel to L. So I like to go in and mark what I know on my picture. So J is parallel to K. I can mark that with these arrows. And then K is parallel, I'm going to mark separately, K is parallel to L. So that's what those little arrows mean. Now what I'm trying to prove is that 1 is congruent to 3. So you might come down here maybe in a different color and mark that 1 is congruent to 3. That's what we're trying to prove. Now you do not know that at all. So you can't say that until the very last statement, the very last thing that you say. So we're going to start with these, like where you can just step by step. We're going to do some fill in the blank before you write your own. So remember, the first statement is always going to be your given. So I was given the information that J was parallel to K and that K was parallel to L. I know that because I was told so. So that was given. So now the next statement in that, remember where I'm trying to go, and that's why I like to mark where I'm trying to go in the picture so that I can look at what I have and where I'm trying to go. So if I know that J is parallel to K, so if I know this is true, then there are several things that I know. I know that 1's congruent to 4 because they're vertical. I know that 1's congruent to 5 because they're alternate interior angles. And so there are several steps I could go through, but I'm trying to get over there to 3. And so I'm going to go the shortest way I can go. And so I'm going to go straight from to 1 is congruent to 2. So 1's congruent to 2. That's why they chose that step. I know that 1 is congruent to 2 because we said the the corresponding angles theorem says that if lines are parallel, if lines are parallel, and I shorthand this, and that's okay if you do too. If lines are parallel, which J is parallel to K, we said so in the beginning, right? We already have that in our proof. If lines are parallel, then corresponding angles are congruent. So I can say that 1's congruent to 2 because we have that theorem as our justification. So I have 1 is congruent to 2. Well, I was also told that K is parallel to L. So I can also look at this. So I can look at those. Now, I know 2 is congruent to 6, 2 is congruent to 5, 2 is congruent to 3, but where I'm trying to get to is 3. So the next thing that I can say then is that angle 2 is congruent to angle 3. Notice they gave you the hint of using if lines are parallel, corresponding angles are congruent. So you would want to, this is your hint that you need to go find some corresponding angles. So now I look at the first 2 steps that I had. I look at this step and I look at this step and I figure out how to get to, well, if I know that 1 is congruent to 2, so I know if 1 is congruent to 2 and 2 is congruent to 3, wait, I can just skip the middleman and go straight to 1 is congruent to 3. So 1 is congruent to 3, and that was because of that transitive property, that special substitution property. Okay, so I have put, now notice I didn't write proof. That's the part I'm trying to prove. You can't put anything else. You have to have a reason behind putting that one there. Okay, so problem number 2, let's label what we know. We know that A is parallel to B, and I also know that C is parallel to D. So that's all I know so far. The reason I know that is it was given information. That will always be your first step. So now their next step, and I also, let's go ahead and mark it. I want to prove that 1 is congruent to 13. Now remember, we talked about in class that you can't go from this vertex over to that vertex because it's on different transversals. So you have to change trains to go on over to that other the other vertex at 13. And so we're going to have to work our way around this to be able to prove that those are congruent. They're not congruent because they're corresponding or alternate interior or anything like that. We're going to have to prove it. But what I do know is that 1 is congruent to 12. Okay, so I look here. I know that 1 is congruent to 12. And this is not the only way to work this problem. This is just the way we're doing it this time. So 1 is congruent to 12. I know that because if lines are parallel, and in this particular case, I know that that means that C is parallel to D, right? So I can go from 1 and I can slide this down that transversal and go from 1 to 12. If lines are parallel, then alternate interior angles are congruent. On Pearson, it'll just say the alternate interior angles theorem. Then I know from there, I know because I know these lines are parallel. Remember, I got 2 is congruent to 13. So I'm looking for ways to connect from where I started to work my way around this shape. For the same reason, if lines are parallel, now in this case, I'm talking about A is parallel to B. You don't have to put that. I'm just putting it in your notes so that you can go back and look. Then alternate. Oh, I put alternate interior. Uh-oh. That should have been alternate exterior. I apologize. Alternate exterior angles. So then this one is if lines are parallel, then alternate interior angles are congruent. Apologize for that. 1 and 12 are exterior. 12 and 13 are interior. So then now if I look, I went from 1 to 12 and then 12 to 13. So now we can just skip 12, take out that middleman, and 1 then has to be congruent to 13 because of the transitive property. So you're always looking for your reasons is why do I know what I just said, or why can I draw that next conclusion? So 3, you're given that L is parallel to N, and you're trying to prove that 2 plus 7 are supplementary. Okay, that's what we're trying to prove. So the first thing, always, nobody should ever miss this. L is parallel to N. That's given. You should never, ever miss that statement. So then let's use the clues that they have given us. They have said, let's use angle 2 is congruent to angle 8. It's not the only option. I could have started with 1 and 7. There are many things I could have said, but they gave us the hint of 2 is congruent to 8. So 2 is congruent to 8. When I look at that, I can say that that is true because if lines are parallel, like I just said they were, then alternate exterior angles are congruent. That's what the alternate exterior angles theorem says. So if 2 is congruent to 8, so remember what I'm trying to prove is that 2 and 7 are supplementary. Well, what I notice is that 7 and 8 are supplementary, or they add to 180 degrees because they are a linear pair. So you would say it's the definition of linear pair. Okay, now from there, if you look, I can take this 8 and this 8, and I can replace it with this 2. So, and they gave you a hint that it's going to be substitution. So I'm going to replace that 8 with a 2, and now I can say that the measure of angle 2 plus the measure of angle 7 is equal to 180 degrees. So sometimes you're going to get things that you know because you're going through steps, and sometimes you're going to just look at them and you're going to know from the picture. And you'll learn how to go through these because they're repetitive. There are only so many ways you can write these problems. So let's look at these. These are ones we're not giving you any hints, but so let me show you how to go through these. So you are given that G is parallel to H, and you are given that angle 1 is congruent to angle 5. I want to prove that angle 5 is congruent to angle 3. Now notice that 5 and 3 are not on the same transversal, and we don't even know about these two lines right here. We don't even know that they're parallel or anything, so you can't go there because we don't know that. You can only use what you know. So the first thing that I know is that G is parallel to H, and that angle 1 is congruent to angle 5. Now, I always mark everything, mark all of my givens. I like to use my givens as I like to use the given and then write the next statement. So the reason I know that is it's given. So now, look at your given. You know that 1 is congruent to 5. Remember where we're trying to go. I'm trying to get to 5 and 3. Well, I do know that G is parallel to H because it says so. Well, because I know that, now you're always going to be given things for a reason. Because I know that, I can say a lot of things, but I can say 1 and 2 are a linear pair. I can say 2 and 4 are congruent. I can say a lot of things. But what I want is I want to get from 1 to 3. That's what's beneficial. So I'd say angle 1 is congruent to angle 3. Why do I know that? Because if lines are parallel, and I just said they were right there, right? If that's true, then corresponding angles are congruent. Now, look at what you've got. I went from 5 to 1, and I went from 1 to 3. Well, now I've just attached 5 to 3 directly because I can take out this middleman of angle 1. So I can go straight to saying that angle 5 is congruent to angle 3. And I know that because the transitive property allows me to take out that middleman. Okay? Last one CD is parallel to AB. Always mark it. That's going to mean something in a little bit. And angle 1 is congruent to angle 2. That means that AD is a bisector. We won't need that, but it is something that is true. So the first thing we always write is we write our given. Our given information is the first thing. That's what we're going to base everything off of. So angle 2 is congruent to angle 1. I know because I told you so. Now remember, what we're trying to get to is that 2 is congruent to 3. So I have to figure out how I can use parallel lines to get there. So y'all, if you're using parallel lines, it's going to come down to one of those 4 angle pairs. So look for those 4 angle pairs. Well, what I know, based on these 2 lines being parallel, I know then that angle 1 must be congruent to angle 3. Because if lines are parallel, and I just told you that they were, then they are alternate interior angles have to be congruent. So I know that 1 is congruent to 3. Well, now look at your picture. I said 1 is congruent to 2. Then I said 1 is congruent to 3. Well, if that's the case, then I can take out that middleman of angle 1. And I can say then that angle 2 must be congruent to angle 3 because of that transitive property. Also, here you might put substitution because of the way that I wrote it. But remember, transitive is just a special version of the substitution property. So anytime you have 3 pieces and you're going to take out the middle, you can use transitive. It is technically a substitution property, but transitive is better because we're taking out that middleman. So you always have to start with what you're given. You use what you're given and the things that you know to process through and try to get to what you are trying to prove. But why you know that